Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Tony Hemmelgarn, who is the CEO of Mentor, Siemens PLM software, which is sort of somewhere in there, right?
Digital industry software.
Okay. So
sure. There we go. Now.
They don't have to hear me, they have to hear you, so. We got sound.
Now, can you hear me now? Yeah, so I'm sorry, it was Siemens Digital Industry Software is what we represent, which is the combination of everything software about Siemens.
Okay, well this is an interesting marriage of two different worlds. So let's start out with where we are today, which is DAC, and looking out at the EDA industry. How do you see it evolving? Will EDA be more or less essential in 5 years from now? And if so, why? What will it look like?
Well, I think part of the reason we did what we did as Siemens was we saw where this market was going, not just EDA, but how it fits into the rest of what we do with software. I think from the beginning it was very clear as to, on the system side, it made a lot of sense. Right, when you think about printed circuit board, wiring systems, wire harness, electrical systems, embedded software, all those things fit very well into what we would call the discrete side of our business that we've always done. And then there was a question on the integrated circuit side, and what does that mean? And I think it's been quite surprising for a lot of people as well. We've grown that business, we continue to invest in the business, we see a lot of touch points that really become quite interesting between our organizations. And it's also the market changing, and that is, we see more and more systems companies getting into designing their own integrated circuits. What does that mean as far as how do we expand? I know the team of the majority of the people that came from Mentor get tired of hearing this from me, but the Chinese market is extremely important to us. And the reason I said they're tired of hearing it is I said they don't necessarily understand what the Siemens brand means in China. And frankly, it was hard for me to understand even when we came into Siemens 11 years ago. But I'm telling you, the brand name of Siemens in China is a very, very unique level. I was there last week for a number of meetings. They are all over us about what we do with the integrated circuit space, what do we do in EDA, what do we do with everything we do with software, because we've had a partnership in China for 100 years of how we work together as companies, and it's a big leverage point for us. So it's how do we go to market together, how do we leverage our adjacent products where they touch each other, and then also how does this thing evolve going forward. And so we see this integration of all of these characteristics a key part of why EDA is so important to us in this space.
So basically you started out at a fairly high level of abstraction on your business model with places like China, right? And now what you're doing is dropping it down all the way into the IC world on a very deep basis?
Well, when I say high level of abstraction, we knew key areas of the integration. Inside of Siemens, we create an integration plan and a document that we follow. And if there's anything about working for a German company, you will follow the document and make sure we deliver what we have to do. So we're pretty good at going through that document, making sure that we've done everything we were asked to do. And I think Wally spoke before. Wally spoke at our capital market event a few weeks ago, and we're well ahead of every target we were asked to do in our plan. But we did have levels of understanding of where we wanted to go, particularly in some of those areas, like I said, in the printed circuit board space and wire harness and other types of areas, very clear. We knew, heck, we'd been working together for many years before. But in the integrated circuit space, it wasn't exactly clear all the touch points. And I made a statement that 11 years ago, we acquired a company called Technomatics for manufacturing process planning and factory layout and these types of things. And if you go back 11 years ago, we were talking about how we were going to work together, you would have never thought about some of the things we're doing today in integrated manufacturing to where we're doing process-driven product design, meaning as a person is designing the product, they see the factory and the plant as to how it's going to be building that, and they can make design changes and alterations well before you get into those costly mistakes. It's the shift left concept, right? Virtually prove it all out, and we're doing things we hadn't thought about before. And I think the same thing's true with integrated circuit, is that we start seeing things like for example, we have a product a solution for application lifecycle management, which is a requirements management tool called Pavilion. We started looking at how we could leverage Pavilion to gather requirements in the process of doing integrated circuit design, and we started having touch points and people saying, wow, this makes a lot of sense. And so then we start looking at things like IoT and how we could help in the IoT process, the fabrication process, the yield, the output, all these types of things. So there are touch points, and I'm absolutely confident that we'll look back 10 years from now and we'll say, gosh, how did we not see some of these things even 10 years ago? That's how we were.
One of the things that EDA has been trying to push for many years is the ability to take what it does on a chip level and really migrate that up to a much larger system. Is that happening? I mean, you now have the infrastructure to be able to use that. Is it actually working?
I think we're starting. I mean, we have the concept of, with AJ here's in the audience that does printed circuit board work for us, what does it mean to think about how the chips are set into the printed circuit board, into the product, these types of things. But I think the real test will be as we start leveraging further levels of integration and depth of how we work together. There's some obvious things. There's other areas where you say, well, they're very loose. I mean, it's interesting when we look at all the customers we deal with, we can be talking to a customer and they don't even realize we're in the same company together selling our solutions, right? But I think you'll start seeing that change as we start coming together as to how we integrate some of these products. And again, it's everything from things like IoT, it's things like data management, it's requirements management, all of these things, I see it coming together very well.
A couple of things have changed at the leading edge nodes, which is where EDA used to really have a lot of its revenue, where it really shown as this is the most advanced thing, is a lot of the designs that are being done at the leading edge are very customized. They're not, you design it once and it's going to play across a billion chips like it did in the past with a lot of the mobile phones and computers before that. What does this mean in terms of how do you go to market? What do you think about with EDA? What do you think about actually from the Siemens side as well as you start getting into these very customized solutions, particularly with things like domain knowledge, which is going to become more essential?
Yeah, it's interesting when you think about customized solutions, autonomous drive, for example. You see more and more OEMs saying, well, do I want to build my own integrated circuit because I want to optimize for the features that I need? I think Tesla just said that their integrated circuit's 4 times faster for autonomous than anybody else because they've optimized for that. But we take it one step further, and that is, if you're really going to prove out your autonomous approach, and you're going to create a circuit, how do you test all of that and pre-validate pre-silicon? And so when we first got together, we started looking at something like autonomous. So we created a program called Pave 360 where we integrate the ability to look at the design of the circuit, the test and validation of the circuit, the prove out of that with the algorithms that are going to be running on that. So for example, we have a company called DAC that we've acquired as well for verification and validation of autonomous vehicle, right? And so what happens is you look at your algorithms, you want to prove out that the safety requirements are there. Is that vehicle going to stop when you expect it to stop? Is it going to be able to identify the things that are there? So we've coupled that with Veloci and our emulation tools, with our task tools, with our capabilities within the Mentor IC product area, to where we can go to a customer and say, not only do you want to do your own integrated circuit, we want to help you design the best circuit that's already been pre-validated to prove that it'll do exactly what you want to do. And autonomous vehicles is exactly one of those spaces. It's quite interesting. We started getting together and seeing all the pieces we could put together based on all the acquisitions we've done. Some of those were planned, and I'll be frank with you, some of them were not. It's after we got together and we started talking and we said, gosh, look what you've got here, and how we could couple the emulation space with what we're already doing with tasks and validation of driverless programs.
How fast do you think that, coming at it from that side, how fast do you think we're actually going to see autonomous vehicles versus assisted driving, which is where we are today?
Yeah, it's interesting. I travel around, been a lot of automotives just in the last few weeks, and there's 2 schools of thought, it seems. There's the major OEMs that are saying it's a level 2. So autonomous is level 1 through 5. Right, 1 and 2 is everything like adaptive cruise control, those types of things. You start to get to level 5. Level 5 is no steering wheel, nothing. There's no way for you to interfere with that driving. And so there's a number of them are saying, we see 1 and 2, we don't know if it's going to go any further. But then you can also see what companies like GM and Waymo and Tesla and these kind of companies are investing a fortune in solving this autonomous capability. And I think the difference is the perspective that you look at the problem from. So for example, if you're going to do autonomous drive in a ringed fenced area in a city, I think we'll see that over the next several years. Are we going to have full autonomous everywhere, all vehicles, all locations, all over the globe? That might be a little bit harder problem, a 10 to 15 year problem, depending on where you're at, because you've got the edge cases you have to deal with, right? It's weather, it's the one-off cases, and partly, by the way, that's what we do with this validation software that I talked about. There's an estimate to get to full autonomous level 5, you'll have to drive about 8 to 10 billion miles. Well, no one's going to drive 8 to 10 billion miles. And it's not well understood, I don't believe, by some of the analysts. I saw an article, I think it was CNBC or someone a while back, said Waymo's in the lead for autonomous because they've driven close to 9 million miles. 9 million miles. We just said to get to autonomous, you got to do 8 to 10 billion miles. So I don't believe anybody's in the lead just because they might have done a few million more than somebody else. Really, it's about how do you leverage software to be able to validate these edge cases, because what we can do is we can run these edge cases and we can start iterating and we can get to those billion miles just running through the use cases in a programmatic method of solving it, and that's where we bring these pieces together. So in answer to your question, do I think it'll happen quickly? I think in ring-fenced areas in the city where the average speed is 12 miles an hour, I mean, how much damage can you really get into at 12 miles an hour? I think you'll see this happening. Do I think it's going to be, I can drive anywhere, anytime? I think that'll take a lot longer because of what's happening with this. And again, we see two schools of thought with the OEMs and the customers we deal with, and it's primarily based on those two use cases.
When you're talking about these geofenced areas, is it only for autonomous vehicles, or will it be a mix of vehicles?
Oh, no, I think it's got to be a mix. I mean, I don't think you'll ever have a full just autonomous. I don't think that's realistic. I think it'll be a mix, but then it's about how do you communicate to the infrastructure, how do you communicate vehicle to vehicle. We have a slogan inside of Siemens, we call it chip to city for autonomous. It's everything, as I said previously here, about the integrated circuit capability, to the design of the vehicle, to the design of the algorithms for the vehicle, to the design of the city, because you have to have the vehicle communicate to the infrastructure as well. For instance, TAS, when I first spoke to them about when we acquired them as a company for validation, they said, well, there's a lot of work going on for vehicle to vehicle communication, and vehicle to the city. I could say, well, gosh, if we're going to have to wait for the cities to retrofit all the stoplights, the traffic lights, it'll be 50 years before we get there. And by the way, since we're already talking vehicle to vehicle and we have sensors, LiDAR, radar, why do we need that? And they said it was a matter of safety, and that is, if you don't have it and you have to rely on LiDAR and everything else, you might have the distance of 5 car lengths between cars. Whereas if you have vehicle to vehicle, you can start to shrink it down, and that's where you really get to where you need to be. So I think what will happen in ring-fenced areas is it'll be vehicle communication to infrastructure, as well as vehicle to vehicle, as well as vehicle with traditional LiDAR radar, which will still allow you to have non-autonomous vehicles in those areas.
And that communication system adds its own element of complexity, because now you're dealing with 4G LTE, the sub-6 gigahertz 5G, as well as the millimeter wave 5G. So now you've got all these different layers. Some of the signals may attenuate at 100 feet. You've got data coming in from cameras and LiDAR and radar and other cars as well. So this is a very complex problem that has to be solved. Where do you see EDA and also Mentor playing in this?
Well, again, I think EDA is a big part of this no matter where you go and look from, in the direction of what we talked about already with Pave 360. But the reason this is important to Siemens is that we're one of the few companies who can put all those pieces together. We start thinking about what it means to communicate, again, to the city is 5G communication. One of the recent acquisitions we did with as we've acquired Mentor, is the 5G emulation. What do we do for that work? And so we're investing in all of these areas. Do I say that a company will come to Siemens for every bit of that? No, we're always open. We'll use bits and pieces. We already have companies using many of those components from us today, whether they're tier ones or OEMs. And I think it'll continue to evolve. But I'll tell you, if you're talking to automotive companies right now and you're not talking about electric vehicle and autonomous vehicle, it's a pretty short discussion. Because that's where the effort is right now.
Another thing that evolved out of Germany was Industry 4.0, which basically was smart manufacturing somewhere else. Where are we with that? Can the tools that we have today be applied to some of the problems in factories and industries where they're not going to be, again, this mass market type of approach? It's going to be, this is a one-off, this industry's been around for 100 years, and this one's developed its own unique capabilities.
And it's kind of funny with, like you say, Industry 4.0, whatever you call it, whether you call it Industry 4.0 or Made in China 2025 or whatever country's slogan is. Everybody's got a slogan of what manufacturing looks like in this new industrial world. And we were acquired by Siemens 11, 12 years ago. When I said I came through a company called SDRC, which became Unigraphics, and a bunch of companies that came together to become this software entity before we came into Siemens. 12 years ago, 11 years ago when this happened, if you would have asked me 1,000 companies that would have been buying a potential to buy us, Siemens would have not been on my list. And I've been in this business 35 years. I can tell you it would have never been on my list because I thought, why in the world would Siemens ever want to get into this space, right? And so it took a little while, and we talked about automation and the types of things we could bring together, and there was a vision of one person that brought us in, Anton Huber, who's now since retired from Siemens. But he had this vision of saying, look, software and automation, all these pieces have to come together. And he was maybe a little early on it, and then Industry 4.0 hit. And then suddenly it was, wow, this is where we need to be. And so we've been iterating, we've been building. We can do things like virtual commissioning of a factory where we take weeks out of the process. A work cell, a robotic cell, any of these types of things, we can simulate it to the nth degree, we can make it run, we can prove it out, we take the cost out, we've done all this. And probably one of the best examples of when you know it's working is years later now, our competition's trying to copy us. They've made partnerships. You got two of my competitors partnering with other automation companies. Well, I assure you, they would not be doing that unless they're getting pressure from their customers as to what are you doing in this space. And so we think it's really starting to hit stride as to what it means to the overall production process, what Industry 4.0 can mean to everything about manufacturing, design, build, and there's no reason why that doesn't stretch into everything we know about EDA, right? We see it already with what we're doing with PCB. I mean, there's things we can do with IoT, with the printed circuit board development process. There's things we see with the integration of how we bring those components together. I mean, our customers are really excited about what we do there, and as I said earlier, I think the same thing comes true with integrated circuit as we look forward to that in the future.
You were talking about software, and I think the software industry has done an incredible job of raising the level of abstraction. I've yet to see that out of the hardware industry, other than perhaps high-level synthesis. For the most part, it's still incredibly complex, and I think this industry sort of revels in the fact that they could get down to the physics level and make a lot of changes and play around with that stuff. Where do you see these two worlds coming together? I mean, you're now in a company that's doing both of these.
Yeah, it's funny. I think I think we haven't done ourselves a very good service of making things so complex. An example I give, years ago, I was sitting with the CEO of a large manufacturer, and he says, you know, Tony, our CIO, sorry. He says, when I go to the boardroom, I see a lot of discussions about ERP and things like this. He says, but PLM, EDA, these types of things, they're not in the boardroom. And he says, you have much more impact to the success of this company, much more than anything that's going to happen with our ERP system about where we're at. But we're not there. And the reason is, I think sometimes it's particularly in the US, many of the CEO level guys are finance people or whatever, and it's, oh, those engineering guys, they'll figure it out, right, in the corner. Rather than bringing our capability to the boardroom and the difference we can make in these industries. And part of the challenge with that is I think we've made this a little bit too hard sometimes, and I think sometimes we forget about the value it brings. I know in my organization, we have 22,000 software people, and you can't believe how many times we have to have the discussion is, I really don't care about how great your mousetrap is. What's it mean to the customer? What's the value it brings? What difference is it going to make in their business? And it's really hard, and I think that's a problem throughout the entire industry, is we spend too much time talking about our technology rather than the impact to the business. And then it comes back to, we want to make it hard and difficult because we want to show how smart we are. We should be making it how we can make this so much easier so that we can allow it to be part of what really transforms a business. And I think this is true for almost all software companies, as you've got to make it easier, you've got to get to value quicker. And I think there's signs of some of these things coming in how we do this.
Well, part of that's being driven by the fact that the customers have changed, right? In the past, you were selling to a chip maker which designed a lot of things and put together their own IP as well as custom IP that was out there and standardized IP. And then they used their own tools and they created something that would create a chip for a socket. Nowadays, what you're dealing with is a lot of different things where you've got everybody from Google and Amazon designing their own chips, all the way into car companies which are now running the giant system for this is what it's going to look like and how it's going to have to play and how it's going to have to perform. So the customer set has changed, right?
It has, but I think even when you're doing just components of those design, we still made it too hard, and it was still about value, time to market, all the basic things that are there. I think as you discuss, as you start looking, as you bring these pieces together, it's even more important because, I've talked before about this idea of complexity. Complexity is not going to go away, right? And if you tell someone, well, we'll find a way to stop or eliminate complexity in your process, that's really a misleading statement and a foolish statement because complexity is not going to go away. Look at the products. I mean, we argue there's going to be 100 billion connected devices in the next 5 years, right? All this data coming in. How do you leverage your data? How do you use it? What do you do to make decisions about that data? That's creating complexity. What we tell our customers is the best thing you can do is learn how to use complexity as a competitive advantage because it's there. And the best way to do that is set up a digital representation of what you have. So you can make decisions faster, you can make them with confidence, and you can move and do the types of things you need to do. So back to your example of these customers that are doing all of these different things, whether it's the circuit, the manufacturing of the product, all the things coming together, that's not going to go away because, again, that's where the real value comes because you're bringing all these pieces together. And what we like about this, and I think it's the reason that our software performance, revenue, everything we're doing is growing so rapidly is exactly that. Customers now know I've got to use this to create a competitive advantage, to go faster, and if I don't, it won't be long before I'm disrupted because somebody's running faster than me in this space.
I'm not sure if this helps things or complicates things further, but AI seems to be everywhere these days. Even in places it probably is not going to stay, but there's AI being used to develop things, there's AI chips themselves, there's machine learning subset all the way across this. How does this impact the design process from your standpoint, and also because a lot of these things are so new and unique and evolve over time, even within the devices that are used to create, they're used to create and are created with them, how do we add some consistency into that?
Yeah, I recently gave a presentation, and when I was in China 2 weeks ago, I gave a presentation. I said, it's funny. If I start out talking about data lakes, if I talk about machine learning, artificial intelligence, all these types of things, I find that I get a lot of attention from the press. And if I talk about, anything that's blockchain, boy, I get all kinds of interest, even though most people don't even know what we're talking about, right? And so, in this technology space, back to making it complicated, we like to brag about technology and how smart we are and use all those buzzwords and everything else. But then we came back to and we said, there was a guy, Mark Weisner, back in the 80s, talked about the idea of compute, and he used this term, ubiquitous computing, meaning the compute power becomes a part of everything you do every day, how you work. You don't have to think about it. You pull your phone out, you're going to use your phone, it's there and it's relevant for the time you use it. It's very important, it's connected, it does all the things, and I put it in my pocket and it goes away because it's just part of my background. And I think it's the same challenge for us as software providers when we think about AI, machine learning, and these types of things is you shouldn't have to think about it. It should be part of what we bring to the solution set and how do we work. So for example, with the Mentor tools, Clipto, the products that we have today work very well in support of our customers leveraging and designing AI into their chipsets. But at the same time, we need AI built into our tools and our products. So, for example, one of the things we're doing within NX, our CAD tool for design, which we're starting to leverage into a lot of our thought and of all of our products, is back to making the product easier to use. We start to learn. We know how you're using it. We start understanding, and then we start modifying and making changes to the way we present data to you through the user interface based on the way we think you're working and learning. And so I think the real challenge with AI, machine learning, and all these things is how do we make it to where it's part of the foundation of the system that we use, rather than the users having to think about it. It should be natural. It should be ubiquitous. It's part of what I use every day. And I think the companies that can do that first will be the ones that will take advantage of it more than most.
I want to ask one last question because we're running out of time here, but how do you see the impact and what's happening with China and the Cold War with China? How will that affect things going forward? And even if it's solved in the next 2-3 months, does that still have permanent effects?
Yeah, there's different parts of China, I think, in the discussion. One is, the overall market, and I personally I can't believe our two countries will not get this resolved. There's too much there for both of us to not figure this out, and I think there is a path. I'm maybe optimistic about it, but I just can't believe we won't get it solved. China right now, for us in my business, is the #1 software market that I have, growing rapidly. For many reasons, but also part of the relationship of Siemens being in China. So I was there last week for opening a new innovation center for how we think about this Industry 4.0 concept. In Chengdu, which is a city of 20 million people, the mayor, everyone was involved in helping fund this center because they want to bring this technology to their users, to their customers, and they're working very closely with us to do that. The next day I was at the National Electric Vehicle Center in Beijing, where they want us to work with them to help promote electric vehicle, autonomous vehicle, energy optimization, again, investing with us to help build this out. So we see a lot of opportunity there in what we do going forward. So I truly believe those things will be resolved. When it gets to specific companies like Huawei, whatever, then it gets a little harder as to what we do. And I'm not a politician. I don't know where that'll go. I think the best thing is we solve engineering problems, and those engineering problems aren't going to go away, whether they're in China, Japan, Germany, the US, they're there, and I think we will be a big part of that going forward.
I think we're out of time, but Tony Hemmelgarn, thanks for a real fun conversation.
Thank you.